Namaste Gurukulians. Hope all of you are fit and fine at your home. This is our next video lecture of unit electrochemistry. In this session, we will discuss about the electrolytic cell and some basic terms. So first, let's start electrolytic cell. Electrolytic cell. First we discuss about the diagram for this cell. This cell, a reaction for this cell will occur in one beaker. Let's take a beaker. Both electrodes are present in the same beaker. One is anode and second is cathode. These are connected through an external source of electricity, a battery. There is an ammeter to show the deflection. You measure the current. Electron move will from, this is our anode and this is cathode. There is an electrolytic solution is present in it. This is our electrolyte. This is our electrolyte. When current is passed, negative charges and positive charges are separated from the electrolyte. And they will move towards different electrode. This is our electrolytic solution present in the beaker. This is the diagram for the electrolytic cell. When electric current is passed through the electrolytic solution, this solution, a electrolyte, will break down into its ions. Positive and negative charges are separated. Positive charges are moved toward the cathode for the reduction, means reduction occur at the cathode, and negative charges move towards the anode for the oxidation. After reaching at their different electrodes, these ions lose their charges and convert into neutral. So in this electrolytic cell, electrolysis phenomena occur first. When electric current is passed through it, they will convert into ions, and ions reach at their respective electrode for their reduction and oxidation. Reduction occur at the cathode and oxidation occur at the anode. So at the anode, oxidation will occur, and at cathode, reduction will occur. This electrolyte is an aqueous solution. Aqueous solution means water is also present. When we pass electric current through this electrolyte break into its ions. उसके साथ साथ as with this electrolyte, water molecules also break down into its ions. Water will break down into, when electric current is passed, it will break down into H plus and OH minus ion. So hydrogen ion and hydroxide ion, they will also move towards the electrode. So there are the two types of cations and two types of anions are reached at the electrode. Then which electrode will oxidize and which ion will reduce and which ion will oxidize? It will depend upon two factors: nature of the ion and second on their discharge potential. The ion which have lower discharge potential, जिस ion का discharge potential कम होगा, it will discharge at their respective electrode. So let's take some examples for this. We take some examples. There is electrolysis of molten lead bromide. If there is electrolysis of molten lead bromide, lead bromide is PbBr2 because it is molten state, so it is liquid. When it undergo electrolysis, it will convert into lead plus Br2 gas. How it will occur? At cathode, reduction will occur. Reduction means when this is converted, electric current is passed, it will break down into lead ion. 2 electrons are 10, it undergo reduction, it convert into lead. Clear? At anode, there are 2 types of changes takes place. 2 types of changes means one is primary and second is secondary. How it is? Bromine is formed, bromide ion Br minus, it undergo oxidation and it form Br free radical plus 1 electron. This free radical is not stable, it undergo reduction and it undergo oxidation. Both these changes, when ions are converted into these species, up to that we called it primary change. Okay students, this is called as primary change, but this is not stable, then it convert into molecular form. So bromine free radical plus second bromine free radical will join to form free radicals means atoms या ions having single electron या odd number of electrons, so it will convert into Br2 gas. This change is called as secondary change. So this is the electrolysis of molten lead bromide. Let's take more example. If we are going to discuss about sodium chloride. Electrolysis of molten sodium chloride. First is for the molten sodium chloride NaCl. Molten NaCl, it undergo electrolysis. When NaCl undergo electrolysis, it will form in the liquid form molten. When it undergo electrolysis, it will form Na plus Cl2 gas. How it will occur? NaCl convert into Na plus. At cathode, it acquire electron and convert into Na. This is at the cathode. Reduction occur at cathode. Similarly for chlorine, chlorine minus, it lose electron, convert into free radical. This is occur at anode, oxidation. These are called as primary change. Then this chlorine free radical is unstable, so it undergoes secondary change. Chlorine free radical combine, it will form Cl2 gas. This is called as secondary change. This is the electrolysis of molten NaCl. Now we take an example of aqueous NaCl. Aqueous means water is also present in the solution. So let's discuss. When we take aqueous solution of NaCl, then what will happen? When we electrolyze या electrolysis undergo NaCl, it will form Na plus and Cl minus. Some molecules of water also undergo electrolysis because it is in aqueous solution. So water is also undergo, it form H plus plus OH minus. Now these two cations are present at the cathode, या move toward the cathode, and these two anion will move toward the anode. Now which ion will undergo reduction and which ion undergo oxidation? It will depend upon their discharge potential. The ion which have lesser discharge potential will undergo discharge. So at cathode, what happen? At cathode, hydrogen ion have lesser reduction potential, so it will undergo reduction. It accept electron and convert into hydrogen. Then two ions, two electron, it will convert into H2. And in case of anode, chloride has less, so at anode, chlorine Cl minus undergo oxidation. Similarly, electron, then chlorine free radical plus chlorine free radical, they will form Cl2 gas. So at cathode, after reduction, hydrogen gas is produced, and at anode, chlorine is produced. But electrolysis of NaCl. So we can say that when we hydrolyze aqueous solution of NaCl, undergo electrolysis, it will form hydrogen plus Cl2. We can understand it by using this. And in the electrolyte, solution of Na is present, with this OH is also present. So NaOH is present in the electrolytic solution. We can find out electrolysis of any one salt by using this. First is molten NaCl, before this lead bromide PbBr2, now aqueous. So discharge depend upon the discharge potential of the ion. This is all about the electrolytic cell. One beaker is taken, electrolyte is present, both electrode are present in the same beaker. One is anode and other is the cathode. At anode oxidation and at cathode reduction. One cell is taken for the current. Now our next topic is some terms related to concentrations or conductance and conductivity. So our first term is resistance. First term is resistance. As all you know about resistance, resistance is the resistance या position offered in the flow of the current. According to Ohm's law, you study in physics, according to Ohm's law, V is equal to IR. Potential is equal to current into resistance. So from here, resistance is equal to V over I. V is potential which is measured in volt, and I is current which is measured in ampere. So unit for resistance is volt per ampere, or we can use it unit as ohm. In the honors of Ohm scientist, Ohm's law, resistance is measured in ohms. Now as resistance is equal to V over I, potential, by current, we know that potential is work done per unit charge by current. So we can write it W by Q into I. What is work done? Work done is force into displacement. So R will be force into displacement is S, charge is equal to I into T into I, because I is equal to Q by T, so we can write Q is equal to IT. We know about force is equal to mass into acceleration into displacement over I square into T. Now from here we can derive unit of resistance. So unit of resistance is mass is kilogram, unit for acceleration meter per second square, and for displacement it is meter by current is ampere square, and in case of time it is second. So from here unit come out to be kilogram, meter square it is किलोग्राम मीटर स्क्वायर सेकेंड, ऊपर जाके एक सेकेंड और आ जाएगा तो इसी S माइनस 3 एंड एम्पियर ए स्क्वायर. सो यूनिट विल बी किलोग्राम मीटर स्क्वायर S माइनस 3 ए माइनस 2, ए ऊपर जाएगा तो इट इज माइनस 2. सो वी कैन फाइंड आउट दिस इन दिस फॉर्म यूनिट ऑफ रेजिस्टेंस. रेजिस्टेंस की एक यूनिट हमारी इस तरह से आ जाएगी. Now second term is resistivity. What is resistivity? We know that resistance of a conductor is directly proportional to length of conductor and inversely proportional to the cross-sectional area of the conductor. We know that resistance is directly proportional to length of conductor and it is inversely proportional to cross-sectional area of conductor. So when we combine both of these, resistance comes out to be L by A. When we remove this proportionality, there is R is equal to rho into L by A. This rho is known as resistivity. This rho is known as resistivity. So we can find out rho will be equal to R into A by L. It come out to be R into A by L. So it is equal to resistance is ohm. This is the symbol for ohm. Area centimeter square and this is centimeter. So it is ohm. Centimeter is the unit for resistivity. Yeah, we can say that it is ohm meter. These are the two terms, resistance and resistivity. Rho is equal to resistivity ohm centimeter and resistance in the ohm. Okay. Our next term is conductance. Conductance is simply reciprocal of resistance. Third term is conductance. And conductance is represented by G. So what is conductance? Conductance is reciprocal of resistance. So its unit is ohm inverse. Next term is conductivity or specific conductivity. It is important. Conductivity or specific conductivity. This is represented by kappa. K को हम थोड़ा सा इस तरह से मोड़ देंगे, then it is kappa. Kappa is inverse of resistivity. And we know about the resistivity is equal to, अभी हमने जैसे निकाला यहाँ पर R into A by L. Now kappa will come out to be equal to 1 over rho. So it is 1 by R over L into A. So we can write it 1 by R into L by E. Then what is its unit? For the specific conductivity, it will come out to be resistance. It is ohm inverse and centimeter inverse or ohm inverse, meter inverse. So resistance inverse is conductance and resistivity inverse is specific conductivity, or simply we can call it conductivity. We can find out by using this. Here 1 over R, this is G. L by A is also called as cell constant. This is our cell constant and it can also be represented by G star. So we can also write it G kappa is equal to G into G star. This is also symbolic representation for this term. So we have discussed about resistance, resistivity, conductance and conductivity. Now our next term is fifth, it is molar conductivity. It is represented by delta M. What is molar conductivity? Molar conductivity is simply the product of specific conductivity into volume of solution containing 1 mole of electrolyte. What do you mean by volume of solution containing 1 mole of electrolyte? So it will come out to be this. Then 1 mole of electrolyte means it is molar conductivity. So formula for the molarity is equal to number of moles of solute by volume of solution. If it is in ml, then it multiplied by 1000. If molar conductivity definition, we have already discussed that volume of solution containing 1 mole of electrolyte, number of moles will be equal to 1. So we can say that molarity will be equal to 1000 by V, or we can say that volume is equal to 1000 by M. What is the unit for molarity? Molarity is moles per liter. Moles per liter. So here molarity is equal to volume is equal to this. So we can put here volume 1000 by M. So the molar conductivity come out to be specific conductivity into 1000 by M. This is the relation between molar conductivity and specific conductivity. Now we can derive the relation, unit for this molar conductivity. Unit for the specific conductivity, we know this is equal to ohm centimeter inverse. And for this liter can be written as, it is written as centimeter cube inverse. Liter can be written as centimeter minus 3. So here volume unit for the molar conductivity, it will come out to be equal to ohm. This for the ohm inverse centimeter inverse. Ohm inverse centimeter inverse. And for molarity it is moles per centimeter cube. Moles per centimeter cube. This is the unit for the when volume in the ml. It can be written as mole. It is ohm inverse. Centimeter ऊपर आएगा, then it will be centimeter 2 and mole inverse. This is the unit for this. And for the conductance 1 over R, this is ohm inverse. It can also be written as Simon. It is symbol is S. So we can also write their unit as Simon centimeter square per mole. Or we can also write it as Simon meter square per mole. These are the unit for the molar conductivity. Simon centimeter square per mole, Simon meter square per mole. When we find out to relate between meter square and centimeter square, we can say that Simon meter square is equal to 1 meter is equal to 10 to the power 2 centimeter. So it can be multiplied by 10 to the power 4. Both these terms are equal. So we can say that molar conductivity. What is molar conductivity? Molar conductivity is multiplication of specific conductivity having volume of solution containing 1 mole of electrolyte. Our last term related to this is equivalent conductivity. Equivalent conductivity. This is represented by delta equivalent. What is equivalent conductivity? Equivalent conductivity is product of specific conductivity into volume of solution containing 1 gram equivalent. It means we know that normality is equal to number of gram equivalent when volume in ml, it can be multiplied by 1000. It is similar for molar conductivity, where 1 mole of volume containing 1 mole of electrolyte. Here is 1 gram equivalent. So here number of gram equivalent is equal to 1. So we can say that normality is equal to 1000 by V, or V is equal to 1000 by N. So we can put it here. So our equivalent conductivity will come out to be kappa into 1000 by N. This is the relation to find out the equivalent conductivity. Now we can find out unit. What is unit for this? Kappa. Kappa is 1 over R into L by A. So it is ohm inverse centimeter inverse. For normality, unit for the normality, it will come out to be gram equivalent. Equivalent per centimeter cube. So it is equivalent per centimeter cube. This is the unit. We can find out it is ohm inverse. ये ऊपर आएगा प्लस का, it is centimeter square per equivalent. Or we can also write it ohm inverse is Simon. It is centimeter square per equivalent. In case of meter, it is Simon meter square per equivalent. This is the unit for the equivalent conductivity. And for molar conductivity, only difference there is mole in case of equivalent. So we have discussed about the 6 terms. These are resistance, resistivity, conductance, specific conductivity, and equivalent conductivity and molar conductivity. एक बार सभी को हम क्या है, मेन इनके जो फॉर्मूले अभी आए उनको हम क्या है डिस्कस कर लेते हैं. फर्स्ट इज रेजिस्टेंस. वी नो अबाउट द रेजिस्टेंस इज इक्वल टू V over I. This is the first. Second, in case of resistance, resistance is equal to rho into L by A. And we know about resistivity. This is resistivity. It is equal to R into A by L. Fourth term our come out to be conductance, which is represented by G. It is equal to 1 over R. Fifth term is specific conductivity, which is denoted by kappa. It is equal to 1 by rho. It is also equal to 1 by R into L by A. 1 by rho, it is 1 by R into L by A. Sixth term come out to be molar conductivity, which is equal to kappa into volume. Volume of solution containing 1 mole of electrolyte, so it will be 1000 by M. And last term is equivalent conductivity, so it come out to be kappa into V, or it will be equal to kappa into 1000 over L. So these are the relations या different terms which are also used in your numerical portions: resistance, resistivity, conductance, conductivity, molar conductance, and equivalent conductance. Our next topic is variation of these terms with dilution. Variation of conductance, specific conductivity, equivalent conductance, or molar conductance with dilution. So we can say that variation with dilution. Dilution means we add water into the solution. When we increase the dilution of solution, the specific conductivity decreases and all other conductivity will increase. Specific conductivity means that is kappa, which is 1 over R into L by A. So we can say that variation with dilution. As we increase dilution, specific conductivity decreases while all other conductivity, these are conductance, molar conductance या molar conductivity and last is equivalent conductivity. These will increases with increase in dilution. First is conductance. Why conductance increases with dilution? Because as dilution increases, number of ions increases, so conductance is also increases. Then why specific conductivity या specific या simply we can say conductivity decreases? Because it is represented by kappa is equal to 1 over R into L by A. So divide by area. So the number of ions per centimeter square area decreases. Ions are decreases per centimeter square. मीन्स यूनिट एरिया के अंदर आयंस की जो संख्या है वो क्या हो जाती है, कम, विद इंक्रीज इन द वॉल्यूम और विद इंक्रीज इन डाइल्यूशन. सो वी कैन से दैट kappa decreases with increase in dilution. Next term is molar conductivity and equivalent conductivity. There is also kappa. In case of molar conductivity it is equal to kappa into volume, and in case of equivalent conductivity it is equal to kappa into volume. If kappa is increases, then it should also decreases. But there is another term, this is volume. As we increase dilution, volume increases. So we can say that this term is also increases. Equivalent conductivity and molar conductivity will also increases on increasing dilution. This volume increases more as compared to decrease in specific conductivity. So all these terms are related with the dilution. Now our next topic is variation of molar conductivity with concentration. Dilution and concentrations are reverse to each other. So we have to find out these variations for the two types of electrolytes, strong electrolyte and for the weak electrolyte. Variation of molar conductivity with concentration. So for this we draw a graph, variation of conductivity with concentration. We take this graph for the strong electrolyte and weak electrolyte. This is on x-axis, this is our concentration term, and on y-axis there is molar conductivity. So for the weak electrolyte, as dilution increases, molar conductivity is also increases. Here is the increase in concentration, so reverse is decrease in concentration, or we can say that increase in dilution. So when dilution increases, molar conductivity also increases. So with increase in dilution, molar conductivity for weak electrolyte. Weak electrolyte we can take an example in your book for the acetic acid, which is in weak acid. And for the strong electrolyte, we can take example of acetic acid. It will be like this. There is a small variation. It will be like this for the KCl, which is a strong electrolyte. We can say that there is small variation in the, because strong electrolyte, as we increase dilution, strong electrolyte are already completely dissociated into its ions. So there is not so much variations in the molar conductivity for the strong electrolyte, because they are already dissociated. But when we decrease or increase dilution, there is small decrease in conductivity. Why it is? Because इंट्राआयनिक इंट्रैक्शन इंक्रीजेज. इंट्राआयनिक इंट्रैक्शंस मीन्स जैसे आयन्स आपस में क्या एक दूसरे को ज़्यादा अट्रैक्ट करने लगेंगे, जिसकी वजह से जो मूवमेंट है आयन्स की वो थोड़ी सी क्या हो जाती है, कम हो जाती है, जिसकी वजह से मोलर कंडक्टिविटी कुछ कंसंट्रेशन इंक्रीज होने के साथ डिक्रीज हो जाती है. ठीक है. सो दिस इज द वेरिएशंस फॉर द मोलर कंडक्टिविटी फॉर द वीक इलेक्ट्रोलाइट and this is for the strong electrolyte. So all this is we have one point is also according to D by Huckel-Onsager equation. D by Huckel-Onsager equation is molar conductivity at concentration C. We can find out molar conductivity at infinite dilution minus A under the root of C, where A is constant, depend upon the nature of electrolyte and nature of solution. We can find out molar conductivity at concentration C, molar conductivity at infinite dilution. This is for infinite dilution. A is constant, C is concentration, molar conductivity at concentration C. Okay students, this is all about our these basic terms and electrolytic cells and variations with the conductivity. We will continue our chapter in the next video lecture. Okay.